Hi everyone, this is Kona, and we're going to talk through how to do the one proportion hypothesis test using Minitab. So first of all, what is our claim? Our claim is that the proportion of men in a randomly selected class is less than 0.45. So that actually shouldn't be a question, it should be a statement, sorry. A national survey found that 45% of the American population is male. So this is where our hypothesized value is coming from, our hypothesized claim value is this national survey. So that's what we're testing against, is this national survey. So first of all, we need to check our assumptions. So in regards to independence, it says are randomly selected, which means it would be independent, but even if it doesn't say randomly selected, in general, we're just going to assume that it was and say yes. Also, here's something that if you're doing this and it doesn't say randomly selected, in general, we just assume independence. So it could be something to talk about maybe in a project of why we assumed independence, even though maybe it wasn't a randomly selected sample, but when you're doing the test, just go ahead and assume it. Now for successes and failures, remember success versus failure, where we're testing for men. So for this one, because our population is men and women, men is a success and women is a failure. And I don't take that wrong because obviously I'm a female, but this is just in terms of what we're testing for. So to figure out whether we have the right success failures, remember we have to have more than or equal to 10, we're going to come into Minitab. So here are our different variables here. We're going to just focus on gender for now, so don't worry about these other ones. We'll go into more of those for the 2 proportion and the chi-square. But for gender, we've got male and female. So what we're going to do, we're going to come over to Stat, Tables, Tally Individual Variables. Then we're going to select Gender, so I just double-clicked on Gender. We want counts, percents, and we want the cumulative counts. Okay, then just click all right. So gender, those 3, click OK. And what we've got is the counts, the percent, and the cumulative. And all of this is what we're going to need, because what we're going to do is take this, remember this is our failure technically, is our percent of females is failure. So we're going to take that, to convert it to a decimal, and multiply it by the 1004. Then do the same for the males, which is considered our success, times 1004. So over here, we take 1004 times the female success or female failures, get 570, which is way more than 10, so that's a yes. And the 1004 times 0.4313, which is the 433, which is also obviously much higher for a yes. So we've checked our assumptions, we're good to go. We then write the original claim, which our claim is the proportion of men is less than 0.45, and that's just from right up here. Is it the null or alternative? Well, less than, there's no equality, so it's going to be the alternative. Something else to remember, we will either reject or support our data once we actually, or our results once we get it. Whenever you are using the alternative as your claim, you're always going to potentially support. So reject, support, all that comes down to is whether your claim was an alternative or a null. In this case, our claim was an alternative, so our option here is support. If our claim was the null, then we would reject. Which tail? Well, for this one, we look at our alternative, and since our alternative is the claim value, which is less than, we know less than is a left tail. All right, so now calculating the appropriate statistics using Minitab. So go back to Minitab. We're going to do stat, basic statistics, one proportion. All right, if you click in this box right there in the middle, it'll bring these up. So we're going to go ahead and select gender. Perform the hypothesis test. For the hypothesized proportion, that's our 0.45. That's what we're testing against. We're then going to go to options, and the 95 is fine. That's our confidence level. Then I've got our proportion. Now remember, we go back to our alternative. Our alternative was a less than, so we use the less than. And instead of method as exact, we're going to use the normal approximation. And that's because we had already checked our assumptions, and that's how we can do the normal approximation. It's just because of that step 1 where we checked both assumptions and they were okay. We then click OK, and here we go. So we're testing, this right here is our alternative, our P is less than 0.45, And remember, what we're actually testing is the event male. So what we want to know is if the number of males, so we had men and women, so here we've got men and women, right, in this column, men and women, but what we're testing is if the event male, so if the number of males is less than 0.45 or 45%. So our X is 0.333, we've got our total number, and we've got our 95% upper bound, which this is your confidence interval right there. Our Z value is negative 1.19, and then our P value is 0.117. So we've got all of that information, but how do we interpret that, right? So it's really important when you go to interpret it. So we're going to come back down here. So here were all the boxes. There's the actual values. So our P is equal to the 0.117. Is that less than or equal to or greater than 0.05? Well, that is greater than 0.05. If it's greater than 0.05, it's always an is not. If it's less than or equal to 0.05, then it's an is. So is less than or equal to 0.05. Is not is if it's greater than 0.05. So is there enough evidence? There is not enough evidence. And why is there not enough evidence? Because we've got a big p-value. Big p-values mean there is not enough evidence. But to make a decision about our original claim, we would come down here. So there is not. Well, the is not comes from here. So there is not enough evidence to reject support. Now remember, the reject support, that comes from up here. If we start with our null hypothesis as our claim value, then we would be rejecting. We started with our alternative, which means we're supporting. So there is not enough evidence to support the claim that the proportion of men in a randomly selected class is less than 0.45% or 0.45. And I don't know why I have that question mark. Take the question mark out, it's a period. So there is not enough evidence to support the claim. So what does that mean? It just means that we can't say that there's less than 45% of the class is men. So that's all we're saying right there. One quick thing here though. I'm going to go back to the Minitab. So that's pretty much done here. So notice we tested males. Well, how was it that it tested males? It tested males because for this one, we've got male and the female here. All right. So it's testing the male first, but what if you wanted it to test the female first? Now it's going to automatically, in this case, test the male. What if we wanted to test the female? We would have to actually code this differently. And it is coding because this is the second. Female alphabetically is first, male is second, and it's going to test the second. So normally it does go alphabetically, which is unfortunate. So alphabetically, male is second, female's first. They're testing that second one. What if we wanted it to be testing the female? In order to test the female, we're going to actually have to code the data a little bit differently. So if you were doing your project and you wanted to test this, but you didn't want to test the male, you wanted to test the female, this is what you would do. So first of all, we have to go to data and code, and we're coding to numeric. Remember, we did this before, so you should remember how to do this. Data, code, to numeric. We're getting rid of religion. We're going to do gender. All right, so for this one, females 1, males 2. But what we want to do is change this to 2 for female and 1 for male. It's fine to add it at the end of the current worksheet. We don't need a show summary table, so click OK. All right, so now we've got 1s are males and 2s are females. Now that we've got that, we can come back and do our stat, basic stat, 1 proportion. So we can leave, or we don't want gender in there because we just recoded this. So we're going to code gender. We use that one. Everything else is the same. So this is if you want to test if women are less than 0.45%. So we would click OK. So now look, you see it's event 2, which event 2 is female, because here's 2 and 2 is female. Also, you can check that the X, which is the number, is 571, which that was our number of women. The 0.56, that was our number of women. And so for here, we get a Z value of 7.56 and a P value of 1. So that was even further off than before. But this is just to show you how, if you wanted to test women instead of men, how you would code the data differently and then just rerun your test. So if you run your run proportion test, double check and make sure the event list the person or what you really are testing. So in this case, male. So up here was correct because we were testing male. But if we wanted to test women, we would have to come down and recode and then retest to get it to work right. So I hope this helps, and please let me know